Good day, everyone. Today we shall be considering partial fraction. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Now let's introduce the concept of partial fractions. Look at these two separate fractions, or these two partial fractions now. If I want to separate if I want to sum up these fractions, the first thing I do is to find the LCM of these fractions. And that will be x plus 2, and x minus 3. And so, x plus 2, go choose the denominator. I will have x minus 3 left, then times 1. That will give me x minus 3. And then plus x minus 3 goes through the denominator. I will have x plus 2 multiplied by 2. And that will give me 2 into x minus 3. X plus 2, sorry. X plus 2. X plus 2. And so, if I simplify the numerator and denominator, we have x minus 3 plus 2x and then plus 4 all over. And if I expand the denominator as well, I will have x squared minus 3x plus 2x and then minus 6. And so finally we have 3x plus 1 all over x squared minus x minus 6. So this is what I have. But the partial fraction is all about taking this single fraction and then trying to bring it back to the partial fraction that led to it. That's what partial fraction is all about. And it's governed by some rules, and we'll be taking those rules, and then we see how we can bring this single fraction back to its separate fractions, or to its partial fraction. The rule number 1 says that if the degree of the numerator is equal or greater to the degree of the denominator, we firstly divide. Now, let me explain what this rule number 1 is saying. As you look at the one here, the fraction here now, you notice that the degree of the numerator is 2, means that the highest power of x is 2, or x is raised to power 2 here, so it's degree 2. And if you look at the numerator as well, denominator as well, if you expand this bracket, what you will finally have is something that have x raised to power 2, so it's of degree 2. And because the two of them are equal, you will have to divide. That's what the rule is saying. If the degree of the numerator is greater or equal, in this case it is equal, you will divide firstly. And look at number 2 also, for instance. Look at this number 2 now. The degree of the numerator is 2, and the degree of the denominator is also 2. You will divide firstly. You have to divide this partial fraction before you start solving. That's what it's trying to say. Now, the number 3 now, for instance, as you look at the numerator and the denominator, the degree of the numerator is 3 and the degree of the denominator is 2. You will have to divide. Why? Because in this case it is greater. So if it's either greater or equal, you will divide. Okay, now look at number 4 now, for instance. We have 3x plus 1 over x squared minus 6 minus x minus 6. The numerator is of degree 1 and the denominator is of degree 2. You will not divide in this case. That's what the rule number 1 is trying to say. Let's consider rule number 2. The rule number 2 states that to every linear factor of the form x minus a in the denominator, there correspond a partial fraction of the form a over x minus a. What this rule is simply trying to say is that if you have a fraction, look at this number 2 now, because at the denominator we have linear factors. The linear factors are x plus 2, x minus 3. And then to separate this partial fraction, all you just need to do is to say a over x plus 2, I've separated the fraction now, plus And because I've used a before, I'm not going to use a again. Now it will be b over the next linear factor. So this is how our partial fraction will look like from this single fraction. In the first case, in the number one, I skipped the number one at first, but let me come to it. The first thing you have to do is to factorize. First of all, factorize the denominator. So upon factorizing, you will have something that look like x minus 2 and x plus 3. So if you do something like this, x plus 2, and x minus 3. So x minus 3. That's what you if you factorize it. And then your partial fraction will be of the form a over x plus 2 plus b over x minus 3. Somewhat like this. Now, for the third case, here we have 3 linear factors. It will be a over x minus 1 plus b over 2x plus 3 plus c over x minus 2. And so that's what we have. So what I'm trying to say is that you will separate every linear factor. Even though it is 4, you separate it a, b, c, d over each of linear factors. Let's take example 1 now. Now, as we look at this question, it says, resolve 3x plus 1 over x squared minus x minus 6 into its partial fraction. The first thing to do, as we look at this question solution, is to, first of all, look at the question and then look at rule 1. That, do I need to divide? Do I need to divide? Obviously, the degree of the numerator is actually lesser than that of the denominator. So we will not divide in this case. We are not dividing. The next thing is to factorize the denominator. If I do that, I will have 3. First of all, numerator is 3x plus 1. On factorizing the denominator, we have x plus 2 in brackets into x minus 3. This is what I will have. Now, after this, the next thing to do is to separate it using rule 2 to every linear factor. So this will give me a over x plus 2, then plus b over x minus 3. And this is what to do. Then the next thing we have to do now is to, on rewriting the left hand side, that is 3x plus 1 all over x plus 2, x minus 3 is equivalent to join the two partial fraction. That is x, the LCM is x plus 2 and x minus 3. And so if I join, x plus 2 goes to the denominator, will give me a into x minus 3 plus b into x plus 2. So this is what we have. And now look at these two fractions. They have the same common denominator, so we eliminate the common denominators. So we have hence 3x plus 1 being equivalent to a into x minus 3 plus b into x plus 2. From here, there are two ways to solve this question. There are two ways these questions can be solved. And then let's look at each of those methods. So I will be doing the two methods here. Method 1, and then method 2. The method 1 is by substitution. Because what we are looking for now is to get our A and B. The first thing to do is to see what we eliminate A. To eliminate A, all we just need to do is to equate the bracket, the linear factor in front of A, to 0. That means equating x minus 3 to 0. If I do that, I will have x being equal to 3. And so I will say let x be equal to 3. Let x be equal to 3 in this equation above. If I do that, I will have 3 into 3 plus 1 on the left hand side is equal to a into 3 minus 3 plus b into 3 plus 2. Then at the end of the day, we have 10 on the left hand side is equal to a we cancel out because 3 minus 3 is 0, b into 5. That's what we have. So on dividing both sides by 5, you get b equal to 2. The next thing to do is to take the second bracket by b into x plus 2, equate that x plus 2 to 0. If we do that, we get x being equal to minus 2. And so if I say let x be equal to minus 2, I will have 3 into minus 2 plus 1 on the left hand side being equal to a into minus 2 minus 3 plus b into minus 2 plus 2. And so you see, minus 2 plus 2 will give me 0. That is gone. And then 3 times minus 2 will give me minus 6 plus 1 equal to a into minus 5. So at the end of the day, we have minus 5. Minus 6 plus 1 will give me minus 5 equal to a or minus 5a. And so dividing both sides by minus 5 will give me a being equal to 1. So I've gotten my a value and my b value. Let's just do method 2. For the method 2, we are solving to result to partial to simultaneous equation. What we just do is that take the left hand side of this marked equation, 3x plus 1 equal to, expand the right hand side. That will give me ax minus 3a plus bx plus 2b. And then we do what we call comparing coefficients. Compare coefficients. And how do we compare coefficients? It's quite very easy. First of all, you compare the coefficient of x. What it means is that as you look at the left hand side, what are the things that have x? What we have here is 3x. So write the 3 without the x. 3 without the x equal to, look at the right hand side, the things that have x, write them without their x. The first is ax. I'll write a without the x. A. The next one is bx. I'll write the b without the x plus b without the x. That's my equation 1. Now I will compare constants. I've compared x. I will not compare constants now. For constants, what do we do again? The same thing. On the left hand side, what are the constants? Constants are terms without x or without a variable. And so that is 1. Now on the right hand side, what are the constants? It's minus 3a. And then plus 2b. So at the end of the day, this will give my equation 2. So we then solve these 2 equations simultaneously. I'm not going to show the steps, but if you solve, you will have a being equal to 1, and then b being equal to 2. So we are done getting our a and then b. The next thing again is to look back at the partial fraction we separated. You know, when we started, we say it is a over s plus 2. Actually, that's the reason why I want to get our a. This is what we have for this part, a over s plus 2. So I'm going to take back this partial fraction and just put the value of a into them and the value of b into them. You know, my a is 1, so I'm going to, it's like putting 1 over s plus 2 and then putting 2 over s minus 3. That's my final answer. So if I want to write my final answer now, it will be like this. First of all, take the question. The question says 3x plus 1 over x squared minus x minus 6, minus 6. So it's equivalent to a, which is 1 over x plus 2 plus b is 2 over x minus 3. So that is my final answer.